So again, welcome to Statistics course. This is our lecture unit 3, lecture number 1. Again, this lecture we're going to discuss about frequency distributions. Frequency distributions is the beginning of descriptive statistics. It's one of the first topic in descriptive statistics. Again, as we said in our earlier lectures, statistics consists of two major parts. We have the descriptive statistics, and the main goal of it is to try to understand our data and also to explore the data, finding the central tendency, dispersion of the data, etc. Then we have inferential statistics. The whole concept of inferential statistics is we're trying to do some studies and we are going to get a sample data from the population. Then we are going to test the sample data. Then the decision that we get from the sample data, we are going to apply it to the population. And we have different ways of testing our sample data. The most common method is using the hypothesis testing, which will be one of our future topics. So again, this is our beginning of descriptive statistics, frequency distribution. The concept of a frequency distribution, again, is to organize our data. So when I have a data set and we have raw values, again, it's very difficult to understand the data or to find a pattern within the data. So we can organize the data in some ways that we can understand it. Two forms of organizing data. We can use the table form, which we call the tabular form, which is the frequency distribution table. Or we can use a graph, such as histogram, dot plot. So we have different types of graphs. So let's start with our frequency distribution topic. So the first thing is the definition. So here we say the frequency distribution is a summary technique that organizes data into classes and provides in tabular form a list of classes along with the number of observations in each class. So we can see that from the definition, the main goal is to organize our data into different classes. And we are going to count how many the frequency of each class. So again, we're going to see an example soon. So how do we construct a frequency distribution? First, we need to choose the classifications. We're going to organize, we have a data set, we can organize the data set into different classes. Let's say if it's a qualitative data, and I have different colors of vehicles, let's say cars, I can organize my data based on the color of the cars. Let's say yellows, blue, green, how many cars I have with green color, how many cars I have with yellow color. So that the how many section will be our frequency, the total tally. And in this case, our classes will be based on the color of cars. Now, we can also have a quantitative data, such as salary. So we can have our first class that all the employees that make between 10,000 to 20,000, how many of them we have? That's our frequency. Our class is between 10,000 to 20,000 salary. Now from 20,001 to 30,000 salary gap. So in this case, our classes will be the salary gap. Then the frequency will be how many people make that income within that very interval. So this is the procedure as we said. First, we need to choose our classification. Then we count the number in each class. So that will be the second step will be our frequency column. So in this case, we're going to have two columns, one for the classes. If they are different cars, the color of then the frequency will be, we count the number of cars with different color in each class. So example is given here. Here we say Lewis Harris and Associate Incorporated conducted a poll of 1,250 adults to determine how Americans grade the school system. There were 24 questions in the original survey, producing a total of 30,000 pieces of data. Without some way of summarizing, this data will not produce usable information. So our goal here is to, again, summarize our data or organize this data we have. That's 30 pieces of data set. Now, the summary tables are much more informative than just looking at the 1250 observations for each question. So here we have conducted a poll of 1250 adults to determine how Americans grade the school system. We have 24 questions in the original survey, which give us a total of 30 pieces of data. That's a lot of data. And then with that, putting this data in some formatting or organize it in some formula way of formatting, it will be very difficult to find any pattern in the data. This data, we can organize it either using graphic, such as histogram or whatever, or frequency distribution table, and that's what we are doing today. So the frequency distribution for the first two questions are shown here. So here we have the frequency distribution of responses. In general, how will you rate the quality of American public school? So we have excellent. So this is our classes. Our classes will be excellent, pretty good, only fair, poor, not sure. Then another frequency table we have here is how serious is lack of parental involvement with a child's education? Very serious, somehow serious, only fair, poor, not sure. So again, the first column is our classes. The second column is our frequencies. So excellent, we have 462. Pretty good, we have 288. Only fair, 225. Poor, 225. And not sure is 50. So again, the frequency table here, we are using a qualitative data. So here we can see excellent, pretty good, only fair, poor, not sure. These are qualitative. We're also going to see the example where we can use quantitative to, again, create the frequency distribution table. So in the next two tables, relative frequency distribution are calculated. So frequency is how many total tally in each class. Relative frequency means the proportion of each class related to the total numbers we have. So it's like finding the percentage of the whole data set. So when we go back again, here, I have to know the total amount I have here. Let's assume, okay, the total amount here is around 1,500. So if I divide 462 by 1,500, that will give me the relative frequency for excellent. So relative frequency is more or less like the proportion related to the total of the items. And we're going to see an example in a second here. So here we can see that in general, the same question, how you rate the quality of American schools, the relative frequency. Again, we divide. So when we had all this percentage, we should get 100 because we are dividing each frequency for each class by the total. So when you had all this percentage, it should be 100. Here we said a poll also reveals that the lack of parental involvement with a child's education is considered very serious or somewhat serious by 82% of the adults who took the poll. Now, summarizing qualitative data using a frequency distribution table or relative frequency distribution table allows the researcher to make a conclusion about the data without having to view each observation. So the relative frequency section can give us the percentage or the proportion of each category related to the total items. Now, in this section, we saw the steps of creating frequency distribution table using qualitative data. It's only 2 steps. You have your classification, let's say good, poor, not sure. These are qualitative. So I have 3 classes. Then a second column will be the frequency, the total tally for each category. Then the third column will be a relative frequency. we divide the total tally for each category by the total of all the items, and that will give us the proportion of each category, which is called the relative frequency. Now, next, we are constructing the frequency distribution using quantitative data. So here they say first we need to decide the number of classes we want. Because if I want to construct a frequency distribution of a salary, and the lowest salary is 10,000, the highest salary is 100,000, I may decide to have only 2 classes, which means maybe from 10 to 50,000, from 50,001 to 100,000. Or I may decide to have 4, from 10 to 20, 20 and 1 to 30,000, etc. So it's not the same as qualitative. In qualitative data, the number of classes depends on the number of categories we have. If I'm talking about the number of cars and the different colors of cars I have is 5, then the number of my classes will be 5. If all the colors I have is 20, then the number of my classes will be 20. This is for qualitative data. Now for quantitative, the steps is we have to decide on the number of classes. Here we say usually between 5 to 20. Otherwise, it may be difficult to detect any patterns. So if we make it only 2 or 3, maybe we can't see any pattern. So it should be at least minimum of 5 or more, but not more than 20. Then second, we need to find the class width. The class width means I have a salary. Should I use from 10 to 20,000 or from 10 to 50,000? The class width will be the 10 to 20 or 10 to 50,000. So we need to determine that. Again, we have a formula that we will see example. We are going to use a formula to determine the class width. Then determine the range. In order to determine the class width or find the class width, we need to determine the range of the data. We know range is always the difference between the minimum and maximum value. Then we divide the range by the number of classes that we chose. So first step, there's no any calculation. We just have to decide the number of classes we want. We need to find the class width. The way of finding the class width is to find the range of the data, look at the minimum value, the maximum value, find the difference, then divide by the number of classes that we have, that we chose or we have. Then from there, we have our class width. Then we can, for example, if the class width is 10.3, we can run it up to 10 or 11. So run it up to the next convenient number. Then the next step, we need to find the class limits. So we know the class width, but we don't know the limit. Now here we can use the minimum data entry as the lower limit of the class. The limit means, we know class width is, if it's from 10 to 50, the class width is 40. Limit means my maximum value is 10,000. My minimum value is only 10. So where should the limit start? The limit are 2, the lower limit and upper limit. So I can say, okay, the lower limit should be 10. The upper limit should be 10,000. The values is from 10 to 10,000. Now there's no way I would say the upper limit is 50,000 because the maximum data in the data set is 10,000. So no need to have up to 50,000 or even 11,000. The lower limit, the value start from 10. I'm not going to use a value greater than 10. Let's say I will start my lower limit from 50, which means I'm going to miss all the data from 10 before 50. So at least to find the class limit, we can say the lower limit should be the minimum value or more, lesser, and the upper limit should be the maximum value or a little bit higher. It shouldn't be less. If maximum value is 10,000, we shouldn't make it 9,000. Otherwise, we're going to miss some values. It should be exactly 10,000, the maximum, or a little bit higher. If minimum is 5, we shouldn't make it higher, let's say 7. Otherwise, we're going to miss from 5 before 7. So we have to start somewhere 5 or 4 and a smaller value. So after that, we find the remaining lower limit. How do we find the remaining lower? If I know the beginning lower limit to be 10, the next lower limit should be 10 plus the width, the class width that we find. So finding the lower limit, we add the class width to the lower limit of the preceding class. And then we find the upper limit of the first class. They say we should remember that the classes cannot overlap. For example, I shouldn't have from 10 to 20, then from 18 to 50. We can see that 18 is already in between 10 to 20. And we don't want to put 18 in another class. So each class, the value should only represent only one class. Then find the remaining upper limit, the same concept. We are going to add the previous to the class width. Then we start to get our frequency now. So make a tally mark for each data entry in the row of the appropriate class. Then we count the tally, and that gives us the total frequency for each class. So let's see an example. Hopefully this example will create the steps for us. So here, the following sample data set list the number of minutes 50 internet subscribers spent on the internet during their most recent section. So the following sample data set lists the number of minutes 50 internet subscribers spent on the internet during their most recent session. Construct a frequency distribution that has 7 classes. So here, they already tell us the number of classes, 7 classes. So first step is we know the number of classes. And second step, so the number of classes, we can say again, the slide here is a little bit overlap, but we can see the number of classes is 7 is given to us. Second step, we find the class width. So what is the lowest value? The lowest value is 7. The highest value is 86. So the class width will be the maximum value minus the minimum value divided by the number of class. The number of class was given to us to be 7. And when we look at the data set, the maximum value is 86, the minimum value is 7. So we have our answer to be 11.29. We need to run it because the number of classes cannot be a decimal number. It's like saying how many children I have. I have 11.29 children. They have to be 11 or 12. So we run it to 12. So now we know the class width. We know our lower value is 7, upper value is 86. So here we can go to the third step to get our class width. So here we said the class width will be 12, which is given. Now we know our lower limit, the minimum value is 7. So we can put the lower limit to be 7. We know the class width was 12. So we have 12 to 7 is 19, and that will be the next lower. We have 7 classes, so we have to do it 7 times. So the next will be 19 plus 12, and we keep going. So we get 31, 31 plus 12, 43, 43 plus 12, 55. 55 plus 12 is 67. 67 plus 12 is 79. So here we have our 7 classes now for the lower limit. The same thing we are going to do for the upper limit. Since this is 19, we're going to start with 18. Then we add 12 to it, to 30, 42, 54, 66, 66 plus 12, 78, 78 plus 12, 90. So now we know our lower limit and also we know our upper limit. So we move to the next step to get our tally. So I look at the data set, how many subscribers spent between 7 to 18. So when we count it, it was 6. How many spent between 19 to 30? When we count it, it's 10. How do we count it? Go back to the data 7 to 18, and I'm going back. So this is 7 to 18. So I'll count. I have 1, 7 to 18. I have 2, another 7. I have 17, 7 to 18. So I have 3 now. And And I think that's it, to 18, so I have 4 also. And I think that's it. So let's say if we are using 4, should be 4 or 5. Again, I'll count up to 4, but let's see. No, we miss a lot, so we have 6. Let's try it again. So we are looking at 7 to 18. And let's see, I missed 11 before, and I missed 17 before. So we have 17, 1, 2, 3, then 4, 5, and then one more, 18, then 6. So that's 6. So the same thing we do to all the intervals, because we already have 7 classes. We know the class suite, so we're able to find all the up to 7 classes. So we count all 31 to 42, we have 13, 67 to 78, we have 6. And the total frequency, the total amount we have is 50. So that will be, again, the conclusion of our lectures on the frequency distribution. Again, here also we can find the relative frequency. So to find the relative frequency for between 7 to 18, I will divide 6 by 50, because the total subscribers is 50. Then I will divide 10 by 50, 13 by 50, 8 by 50, 5 by 50, 6 by 50, 2 by 50. And that will be our relative frequency section. When you add all the answers together, you should get 1 or 100%. So again, that's the conclusion of frequency distribution. Again, wish everybody the best, and thank you for your time.